What's happening, dogs? Mr. Allen here with some SAT prep. All right, we have a grocery store sells pints of raspberries and it sets the price per pint each week. The scatter plot above shows the price and the number of pints of raspberries sold for 19 weeks, along with a line of best fit for the data and an equation for that line of best fit. All right. Now we have 4 different questions here, so this is not obviously straight from the SAT. These are some different scenarios that they could give you with this type of setup. So we have the number of pints sold on our y-axis, and we have the price per pint in dollars on our x-axis of this scatter plot. First question, according to the line of best fit, how many pints of raspberries would the grocery store be predicted to sell in a week when the price of raspberries is $4.50 per pint? Didn't we just say that the x-axis was the price per pint in dollars? Yes. And we have that line, the equation of the line of best fit, which is y equals 233 minus 32x. All right. So what can I do with that 450? I can substitute it in for x. We're going to have y equals 233 minus 32 times that 450. Okay. Bust out that TI. This is going to be a calculated problem. So I'm going to type in just 233 minus 32 times 450. And I've got myself 89. So what does that mean there? So 89. 89 what? Let's see here. It says, how many pints would they be predicted to sell? So this is going to be 89 pints. Beautiful. All right. Now, if this were a free response, 89 would be the answer. We would see 89 pints as far as our multiple choice would be concerned on that one. Lovely. Beautiful. Fantastic. Let's go on to question B. For how many of the 19 weeks shown was the number of pints of raspberries sold greater than the predicted by the line of best fit? So this is where we're looking at that line of best fit and the scatter plot right there, the points that are above, right? Because it says for how many of the 19 weeks shown was the number of pints of raspberries sold greater than the prediction, right? So the prediction is the line. How many are sold greater? Well, let's count them up. We got 1, 2, 3, 4, 5, 6, 7, 8. We have 8 then for part B there. There's going to be 8 times that it's greater than the predicted, all right? So a lot of times on those with the multiple choice, I know there's a couple that are a little close there that might be iffy, like they're kind of on the line. They'll usually give you something that's a little further away from 8 that's like definitely not the answer there, right? The main thing is that you're above there. We could have asked the same question and said, when was the amount sold less than the prediction? Then we would just count the dots that are below that line of best fit. Lovely. Now we got part C. So what is the best interpretation of the slope of the line of best fit in the context of this problem here? So my slope here is negative 32, and x represents the dollar amount. So this means that for every, let's see here, our x-axis is dollars, right? So every increase of $1, every time I plug $1 in there, $1, it goes down by 32. If I raise the price to $2, it goes down by 32. Again, so 64 in total. If I plug in $3, 96, so on and so forth. So for every dollar increase, we sell 32 less pints of raspberries. That would be our interpretation in the context of this problem. Every dollar increase, we decrease the pint sales by 32 pints. Nice. All right, part D. What is the best interpretation of the y-intercept of the line of best fit in the context of this problem? Well, if we look at this graph here, right, it stops at $1.50. We have $1.50 is our start point. That's not where the y-intercept is going to hit, right? It's going to hit when it's 0. So if I plug 0 in here, that means we're charging 0 for the pint of raspberries. Does that really apply? Are we going to charge $0 and just assume that 233 people are going to pick up these raspberries and not just everybody's going to be like, oh, free raspberries, I'm getting these, right? So in this case, there's likely to be a choice here that says it doesn't make sense in the context of this problem to have a y-intercept. This is not a reliable model when we have a price of 0. It just wouldn't make sense in the context of this problem. So kind of weird one there for D, but really wouldn't make sense in the context of this problem to have a y-intercept. 0 is not going to be the price. That's pretty much it. That's dope. Boom. That's a dope problem right there. That's a dope problem. Let's continue. All right, we got a store is deciding whether to install a new security system to prevent shoplifting. All right. Based on the store records, the security manager of the store estimates that 10,000 customers enter the store each week, 24 of whom will attempt to shoplift. That's a no-no, kids, all right? Based on the data provided from the other users of the security system, the manager, all right, estimates that the results of the new security system in detecting shoplifters would be as shown in the table below. So we have ourselves a frequency table here for this one. So up top there, we got the alarm sounds, it does not sound, and the total, which we said was 24, right? Then we have a customer attempts to shoplift. We got some numbers for that. We have a customer does not attempt to shoplift. Looks like the majority of people are wonderful, right? No shoplifting, bad move. All right, and then we have our totals down there. So our question for this one, according to the manager's estimates, if the alarm sounds for a customer, what is the probability that the customer did not attempt to shoplift? Okay. So we're saying that the alarm sounds. Given that the alarm sounds, what's the total amount that the alarm is going to sound for? It's that bottom part there, total for the alarm sounds, which is 56. All right. Now, the next part is, what is the probability that the customer did not attempt to shoplift? So if they did not attempt to shoplift, it's that 35 right there in my frequency table. So I have 35 out of 56 did not attempt to shoplift when that alarm sounded. Okay, so it was given that the alarm sounded, 35 of them did not attempt to shoplift. So let's see what that is as a decimal. I got a pretty good idea here. We can still plug it in. It is 0.625. So 0.625 would be the probability choice D, and that is dope. All right, now, so that is called conditional probability. Given that something has occurred, what's the probability that this fin about to happen? Okay, so they didn't say out of the total number of people, how many people were not shoplifting that the alarm sounded for. That'd be 35 out of the 10,000. But this one was given that the alarm sounded. What's the probability that the person did not shoplift? There we go. That's it. I've gone over that a couple times. I think we is Gucci, and that's dope. All right. Let us do another. All right. The histogram shown summarizes the distribution of time worked last week in hours by the 40 employees of a landscaping company. In the histogram, the first bar represents all the workers who worked at least 10 hours, but less than 20 hours. The second represents all the workers who worked at least 20 hours, but less than 30 hours, so on and so forth. Okay. So that upper part is not included in each bar. All right. So the next question is, or the question is, which of the following could be the median and mean amount of the time worked in hours for the 40 employees? Now, this is honestly a pretty lengthy process here, but we can narrow some things down rather quick. Okay, our median is that middle value. Okay, middle value, and it says that we have 40 total employees, right? 40 employees. So my median of that, there's not actually a middle number here. It's going to be the average of 20 and 21 there, the middle of those two, right? Wherever 20 and 21 lies, the average of that is going to be my median. Well, let's look at our bar graph. We have got, it looks like 6 people worked between 10 and up to, but not including, 20 hours, right? And then we have from 20 to 30, we have another 17 people. What's 6 plus 17? Well, 6 plus 17 is 23. So that means that these two guys right here are going to lie in that 20 to 30 hour mark, right? That's me. 20 to 30 hour mark is where our median, right? That's our median. Woo, boom. Okay. So what choices are possible here? Well, only choice D can be eliminated. So we have A, B, and C currently to choose from, but we have D, that's out, right? The median there was 32. Okay. So now it comes to the mean, all right? Now, let's see. Okay. So we know for that first entry there, we have 6 people that worked at least 10 hours, right? So let's do this. Let's go with, let's do 6 times 10 hours, right? Plus, we'll do, then we have how many people worked at least 20 hours? We got 17. So 17 times 20 hours. Then we can also add in our, let's see here, next one was 30 hours. So we got 9, it looks like. So 9 people times the 30 hours plus, and then we have 5 people times the 40 hours, right? That's their minimum amount worked. They worked 40 to 50. But I'm doing the low end for this one, so we're just being consistent with that. All right. How many people worked at least 50 hours? We got 1 times 50. And then we have plus, we have 60. So there's 2 people that did that. 2 times 60. Now, how many workers do we have in total? 40. If I take this and I divide all of that by 40, we're going to the average worked, the low end average. So let's plug that all in. And I'm gonna speed this up because this is going to take far too long. I'm going to hit alpha y equals, though, to make myself a nice little fraction, because that's a baller move. All right. All right, when I add that all up, divide by 40, I end up with 26. So what does that mean? 26 hours is the average on the low end, right? These were all the low end hours of 10, 20, 30, so on and so forth. So the average on the low end is 26, meaning these people worked 26 or more here on average up to a certain amount, right? There would be a different average for the high end. Well, we know it's got to be more than 26. Well, what's our only choice that's more than 26 for the mean? It's choice C there with 32. So C is our only logical option that we have for this one right here. Oh my goodness. That one was a doozy. I might skip and come back, or at least just make an educated decision on those three, because that's a lot of time to take up for one of these types of problems. But now you have an idea of what you could do here. But definitely a beefy problem right there. All right, that's dope. The dot plots show the distributions of scores on a current events quiz for two classes of 24 students each. Which of the following statements about the standard deviations of the two distributions are true? So quick thing about standard deviations. The closer our data, or our scores in this case, are clustered around that mean, the smaller the standard deviation. Remember, mean is average. The more spread out, the further spread they are from that mean or that average, the larger the standard deviation is. Very basic explanation of it. So now let's read our choices. The standard deviation of quiz scores in Class A is less than that of quiz scores in Class B. So that means that in A, they're closer packed to the mean. Well, what's our mean or our average going to be in Class A? The majority of those scores are between 3 and 4. So if we were to add all that up and divide by the number of scores, 24, we would get a mean that is between that 3 and 4. Okay, so 3.2 or 3.5, somewhere in there. Now for Class B, our average or our mean is going to be, it looks like 2.5, right? We had an even distribution there between 0 through 5. And they're all super spread out, right? So right off the bat here, I'm picking choice A, man. I don't even want to read anymore, but we will. All right. But choice A there, the standard deviation of quiz scores in Class A is less than that of the quiz scores in Class B. Going to be a smaller standard deviation. They're closer packed to the mean, closer to the average, smaller standard deviation. All right, so B is the opposite of that. It's larger. C says the standard deviation of quiz scores in Class A is equal to that of the quiz scores in Class B. No way, dog, right? Not even close. And then lastly, there's not enough information to compare the standard deviations. I do not agree. We chose choice A. We picked choice A, and that's awesome. You dogs have a great day. We got a whole lot of reading going on in this one. All right. A quality control researcher at an electronics company is testing the life of the company's batteries in a certain camera. The researcher selects 100 batteries at random, important, at random, from the daily output of the batteries and finds that the life of the batteries has a mean of 342 pictures with an associated margin of error of 18 pictures, right? So above or below 342 by 18 for the number of pictures you can take on that battery. All right. Which of the following is the most appropriate conclusion based on these data? So a big thing here is you want to avoid like super specific words when we're talking about looking at our data, making inferences on our data. So let's keep an eye on that for our answers. All the batteries produced by the company that day have a life between 324 and 360. We just said all of them. We're guaranteeing that every single one of those batteries is going to be between them. I don't think so, man. I don't think so, Tim. All right. All the batteries ever produced by the company, have a life between 324 and 360. Very specific, right? Not okay, all right? We know it's not going to be all, and it's not going to be ever. This is just one day, right? This was one day. And then letter C. It is plausible. It's much more soothing, yes? It is plausible that the mean life of batteries produced by the company that day is between 324 and 360, adding and subtracting 18 from that 342. I'm liking C right now. Let's read one more, okay? It is plausible that the mean life of all the batteries ever produced by the company is between 324 and 360. That kind of brings us back to part of B, choice B right there, where we said all of them, the entire life of the company. I'm going to take out D. C is going to be our choice, okay? C is definitely the choice here. It is plausible that the mean life of the batteries produced by the company that day was a random sample from that day, right, is between 324 and 360, given that we had that margin of error of 18. So plus or minus 18 from that 342. Beautiful. Choice C it is. I'm confident. C, I don't know which way that needs to go. Confident that is choice C. Dope. All right, we got to interpret some stuff here from a lot of words. Ooh, man, it's like the reading section. A community center offers a Spanish course. Nice. This year, all the students in the course were offered additional audio lessons. They were offered them that they could take at home. The students who took these additional audio lessons did better in the course than the students who did not take the additional audio lessons. Let that be a lesson, right? Study mo. Study mo. All right. Based on these results, which of the following is the most appropriate conclusion? Let's take a look at the first. Now, big thing here with these is looking for specifics, right? Specific words like all or everything or never and stuff like that, right? We want to avoid those with these, okay? And then also we want randomness, right? We don't want like voluntarily doing things and stuff like that. So that may be a key role here, okay? So taking additional audio lessons will cause an improvement for any student who takes any foreign language course. We're saying like everything, everybody, it will guarantee an improvement there. It will cause an improvement. That's what they're saying in that one. That seems a little harsh, right? A little too guarantee-y. That's not a word. All right. Taking additional audio lessons will cause an improvement for any student who takes a Spanish course. Again, I don't know if we can say that. Taking an audio lesson will cause an improvement. Some people don't respond to that. So that seems a little too for sure as well. Let's take a look at C. Taking additional audio lessons was the cause of the improvement for the students at the community center who took the Spanish course. What if they were doing some other studying, right? We can't guarantee that it was the audio lessons that were doing that. They may have helped. They may not have helped. Kid may have done some other studying on their own, right? They may have gone to the internets, right? Okay, and choice D. No conclusion about cause and effect can be made regarding students at the community center who took the additional audio lessons at home and their performance in a Spanish course. Man, that's kind of a bummer that I'm thinking it's choice D, but let's talk a little bit more why it's choice D, okay? So who took these audio lessons? Was it randomly assigned to kids? No. Big thing is random assignment or random choice or random selection. We're talking about the making inferences from data. These are all voluntary students, right? These kids volunteered to take this home. They chose to take this home. They are maybe motivated students wanting to study and things like that. So because of this choice here, because of this voluntary action, that can skew the data and it's hard to make those predictions. So really D is the most appropriate choice here. This ain't a good study, yo. This is not a good study to be able to make inferences from and to make some decisions about this data. I mean, great. Yeah, these audio lessons may have helped, but we can't say that's a guarantee. We can't say it's going to help everybody across the board because these are likely kids that want to do that extra work. So maybe a little bias there, all right? Choice D it is. That's dope. That's awesome. You guys have a fantastic day.